Folks, this is the third video section segment on uh, the generative shape design application within the 3D Experience CATIA. The particular item that I'm going to be looking at is the point on curve option. So when you go to generative shape design and within the 3D Experience CATIA and you look at the menu at the bottom of the screen, it looks like that. And if you click on the wireframe, you will see that the point icon is going to be one of the things that you can select there. So once you click on the point icon, you get a menu dialog box like that. And it has a pull down menu. And the pull down menu already in video 2, we discussed coordinates. Now we're going to be looking at on curve. So point on curve. I'll do that in the context of an example. And by the way, when you look at this dialog box, there's several items that we have to discuss. So I'll do that gradually. Okay, so let me go to the generative shape design and start a part file. There we are. And I'm going to say no here. All right. What I'm going to do is create a few items that I don't use them right away, all of them at least, but gradually we get to see what the role of them are. First of all, on that plane, I will sketch. I'll sketch a two-dimensional plot spline. However, this thing that I'm going to be doing in the present video segment has nothing to do with the fact that this is a two-dimensional sketch. Okay, it can be a 3D curve. Exit. So there we have our curve. Then I'm going to on the x. This I did it by the way on the YZ plane. On the XY plane, I will draw a line. And as I said, you may not see what these are used for, but eventually we're going to be using them all. Exit. All right. And then I'm going to create a point. I'll give it some coordinates here. Let me move it, for example, up. And in the x direction. I'll make this thing 200 and yep, there, and maybe 50 there. That's really, these coordinates are not critical. So I just created a point up here, right there. And finally, I'm going to create another point, again by coordinates, but let me make this thing maybe, I'll make this thing 10 or 10. Okay, I'll make it 50. Good, good. And for the x, I will put 100. Okay, so basically I have the curve. I have a line in that horizontal xy plane. I have 2 points. One of them is over there. The other one is a little bit different. And I'm going to create a coordinate system, axis system, at this point. Okay, obviously you can rotate this thing if you want, but just leave it the way it is. And the origin of it is over here, and it's aligned with the global XYZ. It is possible to rotate this thing so that it's not aligned with XYZ. Okay, right now I don't need any of these, so I'm going to hide in this tree. I'm going to hide sketch 2, and I'm going to hide the axis system, and I'm going to hide this point. Okay, this is what's going on. We're going to create a point, but remember the whole purpose is by doing on a curve. That's the purpose of this tutorial, to do points with on a curve. And there's a lot of things here that we have to do. I'm going to explain them gradually. First of all, it says, what is the curve? Distance on a curve. When it comes to selecting the curve, I do that. And what happens, you can see that the radio button distance on a curve is checked. And the distance on a curve, there's two ways to measure it. Let me select that. One is geodesic, the other one Euclidean. Geodesic means that literally the arc length here is 128.45. Okay. Now, if I select Euclidean, it is not the arc length on the curve. It is not the arc length on the curve, but it is the vector that's going from this endpoint to that endpoint has a length of 128.45. That's why it changes. You can see that. For example, if you look at geodesic, that location changes. Euclidean, it changes because in one case it's the arc length along the curve, the other one is the length of the vector from that endpoint to that point. So I'll keep it as geodesic right now. Now, also notice that, let me move this thing, by the way, a little bit on this side, okay, 87 point something. Now, over here, there is there is an icon, okay? There are two icons. One of them says allows you to create the curve right here allows you to allows you to create the curve on the other side of the right here, the line or the arc. Notice that the starting point can be flipped, flip, flip. In both cases, the geodesic distance is 87.455, but this flips the end, either measured from here or measured from there. Now, the other thing that I'm going to do is the following. Put that thing there. Move it a little bit. Right there. Now, over here, there are two icons. One of them allows you to create a point in the middle of your arc. If I click on that, remember this was 81.45. I'll make it actually 81, so that it's ready. It's easy to see right there. Remember this was 81. So if I click on this, notice that this point is going to go exactly halfway between the two ends, measuring in a geodesic sense. In other words, this arc length is the same as that arc length. Now, if I click on this, this was halfway in the middle. If I do this, it's going to use the default extremities. See that? 0, the point 0 is over there. And if I make this thing 1, it's going to be the other endpoint. Let me put this thing back. Distance. Yeah, okay. I think I had distance. It was 81, right? 81. I'll put it back where it was. Good. So what happened is that point number 3 that I created was a distance 0.81 millimeter in the geodesic sense, which means along the arc, along the curve from that end. Now remember, we can flip that if we want, but I'll keep it like this. Now, what if I choose ratio of curve? Ratio of curve length. You click on this. Right now is 0.262. If I make this thing, for example, 0.7, it will be 0.7 of that total arc length. It's going to be right there. Okay. If I make this thing 1, it's going to be that end. So if I make it 0, back to that end. If I make this thing I don't know, 0.4, right there. Now let me put it back on distance on the curve, 81 millimeters. Remember that? Remember that? 81, that's what we have. Good. All right, so we know how these things work. We know the radio button distance on a curve and ratio of curve length. Now, if I select here, see that? Let me say okay. So one point has been created here. Let me do another one. me do another one. Point the curve, but for the reference point, I'm not going to use this endpoint. I'm going to use the point that I just created a minute ago, right there. So what this thing means is that the 81 millimeter, oops, where is that? 81 millimeter is measured from this point along the arc length. Once again, you know how if I flip this, it starts from that point and goes in the other direction. Okay, flip this there. Let me do another one. So make it maybe 15. Maybe I'll make it 20. Right there. If I flip it, it's going to go to that point on the other side. Flip it, it's going to go here. Let me put it back to 81. Okay, good, good. Now, so I have 2 points. One of them was the reference point over here. This is the point that I'm just creating with this. Okay. If I click on repeat object after creation, and I say OK, now notice that it says the first point is point number 4, and point number 4 was this endpoint that I created. Okay, this other point that I created. This was point number 4. Let me start first point. I'm going to use point 3, which is this. For the second point, I'm not going to use the extremity. I will use point number 4. So suppose I want to create between these two, I want to create 3 planes and 3 axis system. Remember, I created an axis system and I hit it. Okay, so create a normal plane, okay, and create an axis system. So when you do that, if the axis system is not there, no problem, you can preview it. But if the axis system is there, it wants you to go and pick it. Now remember, I hit something, it was here. If you want to see it right there, but you don't have to see it in order to pick it, you can do it from the tree and say okay. So look at what happened. Between this point and this point, I noticed that I changed the order of them. This was 0.3, this was 0.4. I want to create 3 planes equally spaced between them, okay, and with the coordinate system. Okay, let me go back here. Notice that these things are all created. If you don't, unfortunately, I can't go and uncheck this. Okay, so let me say okay, and this time I'm going to delete this repetition. Okay, good. Let's try it again. So this time I'm going to go point again. For reference point, I'm going to use this. Okay, and I'm going to use distance along a curve. I'll make it 10. Okay, repeat it. Okay. Oh, the curve I forgot to pick right there. Okay. So we say, okay, repeat it. I'll make it 5 of them. I'll make it 5 of them. And let me actually make 4. Okay. Now the choice is it starts from point 8. Point 8 is that one. So if I want the starting point to be over here, for example, I'll go there. And I want the end point to be this point. That was point, I believe, point 8, that point, okay? And 4 of them. I want the axis system. I don't want the axis system. I just wanted the, third planes. So we say okay, right there. So what happens is that it created 4 planes with a distance equally dividing the distance from here to there. Geodesic distance, geodesic system from here to there. Now, I want to do something else. Let me delete this and delete these points. By the way, I'm going to delete this one. Delete and delete. Okay. Remember, I hit this point. I hit that sketch. Oh, I didn't want to delete the point here. Oh, it's okay. So let me undo this. Just a second. Undo. Control Z. Control Z. Control Z. Control Z. Control Z. Okay. Point 3 was over there, which I don't want. There was point 1 is right there. But there was another point there. Oh, this is the point. There was another point that I hit. I didn't show. Here is my sketch. There was another point that I created here, but I want it now. So let me actually go ahead and do the following. Let me go ahead and this one I want to keep. This one is on the curve. I don't want it. Delete it. All right. Okay. Point number 1 is over here. Let me create another point, which I inadvertently deleted, I think. Yeah, let me do another point and point with coordinates. Okay, so where are we? Okay, that I think that yeah, that's the one that let me move it up a little bit. Right there. Okay, good. Incidentally, I don't want this thing to be the active coordinate system. I can just say not set as current. Good, good. Now, let's try to do it again. In other words, a point on a curve. The curve is here, but the point that I'm going to take is that point which is not even on the curve. So what happens if this is my reference point? What it does, it drops a perpendicular. It drops a perpendicular. It drops a perpendicular from that point which was not on the curve to the curve, and then this is going to be my reference point. For example, if I say 40 is going to be from that projection point. See that? 60 from that projection point, etc. And then you can flip it again, just like before, except that that reference point is a projection of that. If that point was already on the curve, there won't be any projection. But if the point is not on the curve, it's a projection of that curve. Now, there's something else I want to do here. Distance along a direction. If you select this, notice it's asking for several things. Okay. For example, direction. Direction, I'm going to use this line. See that? See this line? Okay. So what happened, it gives me a point here. And the question is, what happened? So first thing is, that is your reference point. Okay, that is your reference point. It draws a line from this point parallel to that line. So if I start from this point, draw a line parallel to that line, it's going to go like that. It goes by a distance of 10 millimeters. If I want, I can make it 20, by the way. 20 millimeter. So it draws a line from this point in that direction, 20 millimeter. And then when it gets there, it draws a plane that is perpendicular to that line and see where it hits the curve. And that is the point that you're going to get on the curve. So this is kind of an obscure way of doing things, but it does it. So when it comes to along a curve, distance on a curve, or ratio curve length, that's easy to see. When it comes to distance along a direction, from the reference point, it draws a line parallel to that direction, goes by that amount. For example, if I do minus here, it goes in the other direction, by the way. Yep. And then after 20 millimeter, draws a perpendicular plane to that line that it drew and see where it hits the x-axis. As I said, it's a very obscure way of doing things. You may need it occasionally, but I don't use it that often. And that's it. All right, folks. So let's stop this.